Okay, in this chapter we're going to take a look at 3 of the automatic unwrapping tools that actually come with this modifier. The example that I'm going to use here is this mesh that I very quickly put together, and it shows some of the problems that you can have with the very simple mapping methods that we have available to us. If you look at UV map, you have planar. Planar's really not going to give us very good mapping. You can see it's actually causing streaking through here. You know, this is your classical Blackpool rock or candy rock kind of effect, and it's not very good. You can go for cylindrical, and you can see this object is basically cylindrical, so this is probably the one which is going to give us closest to the best results, and you can see that's not bad. It's mapping around pretty good here. We're getting some sort of bunching here, and the checkers are a little bit larger at the side. But again, we're getting some projections going through here, and that's because we've got overlapping areas. Now down here, we've got some streaking going on. You can see streaking going inwards here, so that's not very good either. So cylindrical is not bad, but it's not perfect. Spherical, not very good at all really. You can see you got lots of UVs bunching up here, and we've got the pole down here, so this is actually the correct alignment, but it's not really going to give us very good results. Shrink wrap, again, not great. Box is going to give us pretty good results, I think, but again, it's not perfect. So in some circumstances you're going to find that you're really going to have to unwrap things manually, and of course this is where this tool comes in. So if we apply the unwrap UVW modifier and go into edit, and you can see there are our cylindrical UVs, and you can see they wrap around the object, and as I said, it's not bad actually, but you can see there is some overlapping here, and you could actually massage that with the tools, especially the soft selection tools, to try and get rid of that. That might actually do a pretty good job of that. So just quickly show you what I mean by that. Let's zoom in on the area that I'm editing here, and this is to try and get rid of this overlapping of this area here, which you can see is overlapping this area of UVs here. What I could do is I could turn on soft selection. I'll just change it to UVs and knock that down quite a bit, and we'll just constrain it to this area here. Let's try that, and now let me just try moving this up here, and you can see it's actually kind of unfolding it a little bit. Could try and make that a little bit smaller, maybe. Just move it on a little bit more, and we'll just move it a little bit more again. There you go, that's not too bad. You could do the same for here, and then you could use, maybe if I just selected this area here, you could use the tools that we looked at in the last chapter, the relax dialog, and you could use that to try and relax out that area and get nicer mapping. And you can see it's not doing too bad of a job there. So this is something that Dominic covers in a lot more detail in the next DVD, so I won't dwell on that too much here. If we didn't want to use this kind of mapping, we could use automatic unmapping, and this becomes more useful for when you want to do things like rendering out to texture, and this will actually bake rendered elements into a texture. A lot of the UVs that this system actually puts out aren't necessarily that useful for hand texturing, and that'll become a lot more evident when we actually have a look at these features. So let's do that now. I'm just going to go into selection mode, face, select all the faces here, and we're going to do an unwrap on all of these. And the first option we have, and probably the best option in general usage, is flatten mapping. And what that tries to do is it tries to create clusters of faces. We've covered clusters earlier on in this DVD. That's an area of UVs which are contiguous with no breaks in between them. And it defines those clusters based on face angle thresholds between those faces. So as an example, the default value here is 45 degrees. So any faces that are in this area and which fall within 45 degrees of each other, they will become part of the same cluster. If the angle goes over 45 degrees, then it will qualify as another cluster, and it will then take that face and work out all the other faces that are within 45 degrees of that face and that will form another cluster, and so on and so forth. And it's a completely automatic system, and it's just basically based on this face angle threshold here. It's actually very much akin to the automatic system for assigning face smoothing sets. So you can think of it in that same way if you're familiar with that. So we'll just use the automatic, the default value of 45 degrees. We'll OK that, and you can see what it's done is it's as I just said, it's taken areas that fall within 45 degrees of each other, and it's turned them into clusters. And you can see in some cases it's creating tiny little clusters here. This cluster here I think is the back end of our object, if we have a look here. And obviously the top and the bottom of our arrow, these areas have come out pretty well. But one of the big problems with this kind of system is it does create these massive discontinuity in seams. If you were to take this UV layout into a paint program and try and paint across these seams in a seamless manner, you're not going to be able to do it. Basically, it's not the sort of thing a human can do. What it is useful for is for any kind of texturing system that can take these discontiguous UVs and work out where two UVs would connect, and it will then join those together. And you get those in things like Deep Paint, and I think ZBrush also works with UVs like that. So you can use this system to actually generate a UV layout for that kind of system. If you're going to do any kind of UV layout which is going to be painted by hand, it's probably a better idea to actually do it manually and actually assign your UVs and arrange them by hand. You can use this as a starting point, but it's often very difficult to get a good starting point. And what you end up doing a lot of the time is, this here may be cool, but you'll probably find that this face needs to be welded in here, let's say, and you end up breaking that off and then moving it over there, rotating it and aligning it, and then welding it back in there. And you may find, this face is orphaned, and you really don't want that. Then you're going to have to search through here, find faces that it would normally attach to, and do that whole process, and that can be very, very laborious. So in some ways it's actually better to actually start off by assigning the UV mapping by hand and then tweaking things. So if we go back to the tool, if I use a very low face threshold, that will actually fragment. Oops, let's just undo that. I just had that face selected, that's why it's only done that one. So if we did mapping, flatten mapping, and we went very low with a very low value, we'll just OK that. You can see now that it's looking for only faces which were something like 10 degrees away from each other, and that's hardly any of the faces on the entire object. And it's basically fractured it up into hundreds of clusters, which is really only readable by some kind of algorithm, some kind of programmed system. So that's going to be completely useless for humans. If we go the other way, I'll just select these again, and if we go up towards higher values, obviously at 90 degrees that would be everything, so we'll just keep shy of 90 degrees. I'll just OK that, and you can see now it's created much larger clusters, and those are actually much more useful for a human to work with, and would form a better basis for actually then hand tweaking these and laying these out yourself by hand. Now if we look at this tool one last time, these other options here, these are actually parallels of the things that you will find here in Pack UVs. And basically you've got your spacing, normalize clusters, rotate clusters, and fill holes, and those are actually built into the flatten mapping. So first it actually creates the clusters, and then it actually packs them in for you as one process. So that's the flatten mapping tool. The next option we have down is normal mapping, and what this particular tool does is a similar kind of process again, but instead of using face angle thresholds, what it does is it uses a preset set of mapping types which are based on face normals, and it then breaks up the model based on those mapping types. So we've got back and front, so if I just OK that, as you can see, it's tried to map the model based on back and front. It sees the back and front being based on this plane here, going this way. you've got left, right, which goes in this direction in this case. There you are, there's the UV layout for that. You've got top, bottom, which you can see on this particular object is probably the most successful of normal mapping so far. Still not great, but at least it's pretty coherent. And it's certainly hand paintable, apart from obviously these UVs here, which are completely edge on. So those would have to be unwrapped via a different method if you want to be able to paint those. And then you've got box with no top. This is very similar to the box mapping that we have here, but we don't actually have any top to it. And then you've got exactly the same feature. You've got box mapping, just okay that, and that does actually have a top to it. So it's just doing UV mapping based on 6 directions. You know, here, here, top, bottom, back, front. And then you've got diamond mapping. That's actually exactly the same as box mapping, but it rotates the box by 45 degrees. Hence the the term diamond. And again, in all of these cases, it's got the packing system built into it as well. So it creates the clusters and then tries to pack them into the space. So that's the normal based method. Not particularly great. Might be useful in some circumstances. So it's there if you need to use it. And then we've got the last method, and this one would strike you as possibly being the best system of the lot, but it has got a big caveat to it, and that big caveat is that it results generally in a lot of overlapping faces. And what this system does is it picks a face on the surface and then it walks from face to face, and what it tries to do is it tries to actually unwrap the mesh to create a single contiguous set of UVs. So if we just OK that, you'll see what it does. It's literally like it's got a piece of, as if the object is made out of cardboard, and with a scalpel it's kind of made cuts. And in theory you could actually get this, if you printed this out on paper, you could actually get this object, and by folding it in certain areas and then gluing it, you can actually create this object. It's kind of like a little kit to make this object. But if you look at it in certain places, there's lots of UVs overlapping, and it's not really that useful in most circumstances. It could be in some, but you can see that in this case it's produced a mess, and generally it does produce a mess. So in this version of the tool you now have pelt mapping, and as I said earlier on in this DVD, that's actually covered in the next DVD in this series. So if you want to have a look at pelt mapping, that's something I would recommend that you do, is actually look at the next DVD in the series by Dominic Queck. And pelt mapping is ideal for doing this kind of thing, where you may need to pull a mesh apart and unfold it in a more controlled manner than the kind of automatic system that you've seen here. Of course, with all of these automatic unwrapping systems, you don't have to accept exactly what it's done. You could always go in and you could just say choose these faces here. Let's say we'll just select down to there, and we've actually got ignore back facing on, so I'll just turn that off, make that selection again. There we are. So we could just select those faces there, and if we wanted to, we could go to mapping, flatten mapping, and we could just use quite a high threshold for that, and that should give us a reasonable little chunk there. And I'll use the relative offset here just to move that out of the way. Then you could choose this section here, and you could just unwrap the object bit by bit. And this is more akin to the kind of process that you will actually carry out in the real world. You don't generally select an entire mesh and apply one type of automatic unwrapping or manual unwrapping and then adjust. You tend to do it piece by piece. You choose the best method for each piece, and then you apply the mapping, and then you make adjustments based on that. So let's move on now into the next section of the DVD, where we'll actually carry out that kind of process. And we're going to look at a game kind of level mesh, and it's of a building for a kind of science fiction game. And what I want to do on that mesh is to create 2 sets of UVs. One will be used for hand painting textures, which I've already done, so we won't be looking at painting the textures on this DVD. just purely at UV layout and how to do that. But I've also used the flatten mapping feature to apply UVs so that then I can use the render to texture feature to bake out some ambient occlusion maps, which actually create the illusion of the object being lit with ambient occlusion in real time. And that's a direct application of the sort of thing you do in a real-time game engine. So let's move on now into the second half of this DVD.